Hello, my name is Yogesh Prabhu and today I will teach you Hungarian method of assignment. Now to make you understand this method, I have taken one sample problem. The best way to learn the method is with the help of a problem. Typist has got different rate per hour and they charge differently. Like typist A does 12 pages in 1 hour and he charges 5 rupees per hour. Like that typist B does 14 pages in 1 hour and charges 6 rupees per hour, and so on and so forth. So we have details about all the 5 typists, and if you see here, these are the jobs and they are labeled as PQRST. Now job of a typist has to be typing a book, right? So P is a book which has got total pages 200, Q has got 176 pages, and so on and so forth. So here we have 5 typists and we have 5 books to type. Every typist has got different typing speed and they charge differently. Also, different books have got different number of pages. So now after all this data, now what could be a question? Obviously, the question has to be that you assign a typist to do a particular job in such a way that you do it with the minimum possible cost. So now what we have to do essentially is, we have to figure out what is the cost. And to find out the cost, I have these formulae over here. Let me explain the formula now to you. Okay, so let us take combination of, say, typist A doing job P. What if typist A types P book? If A types P book, I'm talking about this situation here. P book has got total 200 pages, right? And he does 12 pages in 1 hour. So essentially time is total number of pages upon pages per hour. So here, if I have to find time for typist A doing job P, the time will be total pages 200 divided by he does 12 pages in 1 hour. So 200 upon 12. If you solve this, this will be 16.666. I kind of know that. Well, now I want to draw your attention to this note here. Read, the typist is paid for full hour even if he or she works for fraction of hours. Now, the time here is 16.666. That is 16 hour and some more minutes that goes into the 17th hour, right? So he's going to work 16 hours and some more minutes of 17 hour. That means you have to pay him for 17 full hour. That is the condition. That is the employment condition, right? So now read the line here. The next line says that round up the time to the next integer. So you will take this time as 17 hours. That is as per this condition. And finally, the cost is going to be time into rate per hour. So typist A charges 5 rupees per hour, right? And he will take 17 hours to do type book P. So the cost here is going to be 17 into 5. Okay, and that is 85 rupees. So I'll write down 85 over here. Now that way you have to solve for each and every combination, right? And find out the cost of typing. Now let me do one more just to explain to you this procedure one more time. Supposing let's talk about this situation. Every cell of the table is actually a representation. Now, what this cell is telling you, it is typist D. What if he's typing book S? When the typist D type book S has got 300 pages, right? And typist D will do 10 pages per hour. So he will obviously take 30 hours to type book S. And he charges 4 rupees for every hour he works. For 30 hours, it's going to be 120. That's quite easy. So now same way you have to find out for different combination the cost. So this table here is going to be cost of typing. So now let me solve for all of them and find out all the different values. And then once we find the cost, we will figure out how we can minimize the cost essentially, because we want to do the project at the minimum possible cost, right? Okay, I did all the calculations offline and I have this cost matrix. Now in the problem it is asked to assign typist to different books in such a way that the total cost of the project is minimum. Of course, you want to make sure that you spend the least amount of money to get this job done, right? So how do we do that is Hungarian method, and let me explain to you how this method works. Now I'm going to suggest a few things how to go about this particular method, and first thing you should do is write down comments, and they actually guide you throughout solving. Okay, so let me write down comments one by one. The first comment here is we should write down what are we supposed to do. Okay, the first point is this is total cost minimization. So you want to minimize total cost. That's the first point that I want to mention. Now second, I want to check how many rows do we have. How many rows do we have? We have 5 rows and we have 5 columns. Now I want you to note one point. Every row corresponds to a typist. The first row is of typist A, the second row is of typist B, and so on and so forth. And columns correspond to the jobs or the books. And we should write this down, that number of rows, and there are 5 rows, is equal to number of columns, 5 columns, and this gives you the capital N, which is the size of a table, which is 5. Okay, and one more point you should write down, that it is 1 to 1. Now this is actually the most important point of all. Okay, it is said in the problem that one typist will do only one job. So this question is strictly one-on-one, and I'm going to elaborate this a little later. But as of now, let's move on with the solving procedure here. Okay, so the step 1 of Hungarian method is row minima. Now let me explain how the row minimization works. What you do is, say from the first row, choose the smallest value of the row, which is 65, and subtract the smallest number from every number of that row. Okay, so you do 85 minus 65, that gives you 20. 75 minus 65, that is 10. Then do 65 minus 65, that is 0. And then do 125 minus 65, that is 65. And do 75 minus 65, that is 10. And keep repeating this procedure for each and every row. Now in the second row, the smallest number of all is 66, right? Now subtract that from every value of that row, and that is how row minimization is done. Okay, so after I perform step row minima, I get all these values, right? And now let me explain to you what we did here. Okay, we took the smallest value and subtracted from every number of that row. Now, the interesting thing to note here is 0 is the best place to assign. Like if you assign A to R, that is the cheapest you can get your job done. So 0 is actually a nice place. That's the cheapest or the best thing to do in order to save cost. Now I just want you to understand even what is the meaning of number 10. Now this 10 tells you that if you do assignment in this place, which is A does job T, you will spend 75. And in that case, you will be losing 10, you will be spending 10 extra rupees. That's exactly what this step means. But I hope you followed the procedure still. Now after row minima, we perform column minima, which is the exact same procedure, but do it column wise. So now we'll do it column wise. So in the first column, the smallest number of all is 18. So take the smallest number and subtract from every number of that column. So 20 minus 18 gives me 2. 24 minus 18 gives me 6. 18 minus 18 gives me 0. 20 minus 18 gives me 2. And 20 minus 18 gives me 2 again. Now let me do one more for you. The smallest number of the next column is 8. Now subtract 8 from every value. So you get 2, 10 minus 8. 12 minus 8 is 4. 9 minus 8 is 1. 12 minus 8 is 4. 8 minus 8 is 0. Now look at this column. Every number here is 0. So smallest number of all is 0. Subtract 0 from 0. All stays same. They all are still 0. Fair enough. Now the smallest number here is going to be 56. I'll subtract 56 from all these numbers. This is 4, 10, 1, 4 and 0. And the smallest number here is 10. So 10 minus 10 is 0. 2. Fair enough. So I did column minimization exact way I did the row minimization. Now once you did row and column minimization both, now here is a procedure that you have to draw lines to cover maximum zeros. Let me explain how it is done. The rule is to cover maximum zeros, alright? So let me draw this line, because this line will cover 5 zeros here. Now once these zeros are covered, they're taken, so don't worry about them anymore. Now remaining zeros are here, and just keep doing that. Cover remaining zeros with the line. So you got 1 0 here, and you got 2 zeros here. Yes, so you should draw this line, and it covers these 2 zeros. Don't worry about the one that is already covered. Okay? Now you look at the table, you have 1 0 remaining over here and the 1 0 remaining over here. Now you can cover these 2 zeros in whichever way you want. You can draw either vertical line or horizontal line. It's your choice completely. So now let me cover this 0, whichever way is vertical or horizontal. Let me draw it like vertical. And let me cover this 0. And I can cover it horizontal or vertical. It is completely my choice, as I said. So the step that we just did is cover maximum zeros with a vertical or horizontal line. No slant line allowed. Fair enough. So once I get all these lines, you have to count them. So let me count the lines. You've got 1, 2, 3 vertical lines and 4th is the horizontal lines. Now let's say L is number of lines. So you got L is equal to 4. Total 4 lines here. And just see if it is matching with N. N is the size of table, as I said. So you have N is equal to 5. L and N is not equal. Okay, because L is 4 and N is 5. Now, look at the statement here. Whenever your L and N does not match, it is not optimum. You must write down this line. So if your L and N is not equal, it is not optimum. So we haven't got it optimum yet. Now when it is not optimum, there is set of procedures. When it is not optimum, there are a set of steps that you have to follow. First thing, okay, now when it is not optimum, here are the steps that you're supposed to follow. First is highlight your uncovered cells. So these are the uncovered cells, not covered by any lines. So these cells, and even these cells are not covered by any line. So highlight the uncovered cells and figure out change. Okay, and change is the smallest number of the uncovered cells. So what is the smallest number of the uncovered cells? If you see, the smallest number is 1. So change is 1. So okay, let me write that down here. The smallest number of uncovered cells, that becomes change. Now once you find change, okay, what you do is you change the table using that 1 here. So now we will focus on the change. Now the entire table here will change. Okay, and let me draw a brand new table here. So the new table is like this. Say 1, 2, 3, 4 and 5. 1, 2, 3, 4 and 5. Now the procedure is, subtract change from the uncovered cells. So first thing you will do is from all the uncovered cells, you subtract the change, which is 1. So you get 2 minus 1 is 1. 4 minus 1 is 3. Next, what you do is add at the intersection. So you will add here, add here, add here. So add change at the intersection. So 2 plus 1 is 3. 1 and 3. And the last is copy all the remaining values as it is. So you get 2, 6, 0, 2. Now let's take a recap of what we did. We start from here. Cover maximum zeros with the lines. So I covered this first, then I draw this line, I covered these two, then I covered this 0 over here and then this 0 over here. Now you have to be very attentive to this. Now once you cover all the zeros with the straight lines, count the number of lines. I've got 4 lines and the table is size 5 by 5. So that L and N is not equal. Whenever your L and N is not equal, you call it not optimum. And when it is not optimum, you find out a change. Now, what is the definition of change? Change is the smallest number of the uncovered cells. So from the uncovered cells, the smallest number is 1. So the change is 1. Once you find the change, subtract change from uncovered cells. I did that. Then add at the intersection. And remaining values just copy as it is. And you have a new table. And that is pretty much the whole procedure. Now, the same method will repeat for this table as well. So, repeat the exact same procedure one more time. Like, now refer to this table here. And in this table, cover maximum zeros with a line. Like, do you see there are 4 zeros over here? Then you have 3 zeros can be covered like this. Then you have 2 zeros here and 1 zero over here that you can cover like this, 2 zeros. And you have one more remaining 0 which you can cover either vertical or horizontal. It is completely your choice. So now let's say let me cover this horizontal. And exact same procedure, right? So you have now count number of lines. You got 4 lines here and 1 vertical, 3 horizontal, 1 vertical. So you have L is equal to 4 and size of table is still 5. So you have N is equal to 5. L and N is not equal. So you say since L and N is not equal, therefore, yes, same procedure, right? It is not optimum. And whenever it is not optimum, you need to figure out change. Now, change is the smallest. This is a completely iterative procedure. Now it's going to be exact same what we did before. So I'm highlighting uncovered cells. Now once I highlight uncovered cells, I'll write down the change. Change is the smallest number of uncovered cells and the smallest number is 2, right? So the change is 2. Now once you figure out the change, next what you do is you modify the entire table using the change factor. So let me draw one more table here. So you have 1, 2, 3, 4 and 5. 2, 3, 4 and 5. So 3 things. Subtract change from the uncovered cell. So let me do that. This is 4, 3 minus 2, 1, 2 minus 2, 0, 3 minus 2, 1, 9 minus 2, 7, 2 minus 2, 0, 3 minus 2, 1 and 2 minus 2 is 0. So I subtracted my change from all the uncovered cells. Get that done first. And now figure out wherever you have intersection, you have to add change. So you add here that is intersection of the line. So 0 plus change is 2. Add here 0 plus change is 2. Add here, that was 1, okay? So you already have 1, and because it is intersection of the two lines, vertical and horizontal, you will add here, and 1 plus change, 1 plus 2 is 3. And remaining numbers, you just copy them as it is. So you have 2, 1, 3, 0. And you guess it right. As soon as I get a new table, I will repeat the exact same procedure one more time. So let us cover all the zeros with a line. So let's see what we can do. And the rule is still same. You have to cover maximum zeros, right? So I can draw this line that covers 3 zeros here. And then I have 2 zeros over here. Well, but I have 3 zeros here, so I should cover these. That's still a straight line, okay? So I've covered like 1, 2, 3. And I can cover these 2. And I can cover these 2. And still there is 1 zero remaining. So let me cover that 0. And it's completely my choice. I can draw a vertical line and cover it, or horizontal line and cover it. It's completely up to me. So let me cover it like this. Look, now I have L5, that is number of lines. And the size of the table is also 5. So N is 5. And L and N are exactly the same. And since L and N are same, that's exact contrary to what we were getting till now. Since L and N is equal, it is optimum. And that is sure reason to smile. Solve anymore. Because you got the answer. Optimum. The meaning of the word optimum is the best. So you have arrived to the best solution to your problem. That means you're going to get the minimum cost of this project. It's a good thing, right? So now, as soon as you get L and N equal, you stop solving, okay? And you write down the final answer. Now, I recommend to write down the final answer, you should do this. Draw something called as zero table. So, you can imagine what is zero table. Zero table is table of zeros. So, let me draw a zero table, and it goes like this. These are the typists, and these are the jobs. A, B, C, D, E. And jobs are P, Q, R, S, T. Alright. Now once you write down, now let's draw, now for zero table, you write down all the zeros. Whenever you solve any of these questions, you always refer to the latest table. So for zero table, you will refer to the latest of all. So now once you draw a zero table, you have to look for alone zeros. A zero should be alone in the row or column. So you cannot choose this zero, no. But you can choose this zero because it is alone in the row. The zero has to be alone in the row or column. So, and that means that typist A should be given job T. And as soon as you give job T to typist A, now these are cancelled out. Now, as soon as you cancel out these two zeros, you see this zero is alone in the row because this does not exist anymore. So you can assign this zero. So typist B will do job R. So you have to cancel because job R is already taken by typist B, right? Now, if you see this zero has become alone in the row, this zero is not alone in the column, but it's alone in the row. So you can choose this zero and cancel this out. Now here you have got 4 zeros and none of the zero is alone, neither in the row nor in the column. Now when this happens, you can assign just the way you want. So you can assign either these two or you can assign these two. It's completely your choice. So let me assign this and cancel this. Cancel this as well, yes, because C is taken by Q. And I can assign E to S. And that is my final assignment. So I'm going to write down the final assignment. It goes like this. Final assignment. Typist A, typist and job combination. Typist A should do job T. And the cost, let's write down the cost. Let's see what is the cost working out here. If typist A does job T, it is going to cost us 75. If typist B does job R, it is going to cost us 66. So let me write down all the typist and job combination. Now I have written all the typist job assignment, the final answer that we've got, and individual cost of that assignment as well. And it works out to be total 399. And now this over here is what we are looking for. This is total minimum cost of the project. So we figured out the right assignment such that the cost is minimum, and we can do this project in total overall cost is 399, and that is the best cost.